So now we're recording, just for everyone to know. Today is June 28th of 2024. This is the Kubernetes Book Club from the CNCF. And we have Sergio, the book author for today's book or series. We're doing Compute on the Edge with Kubernetes. And we have our lovely host, Sevi. Sevi, some words for today?
I have some heavy machinery working in the background, so try to mute myself.
Okay.
But it's great to have Sergio the third time here, and it's been super fun. So I just am looking forward to the magic we're doing with the Raspberry Pis.
Yeah, very, very cool. I mean, that uh, running Kubernetes on the edge, people may seem that is a toyware, but I think we were discussing one of the beginning sessions. So the start was like people use it on like physical locations like stores or
Hmm.
satellites or like even actually telco. I work with a telco company. I'm going to have to say the name, but yeah, they were putting Kubernetes multi-node Kubernetes on boxes in the where they put the antennas. Like they have like a locker, and they will put like Kubernetes in there to manage all the software and the satellite, the antenna where they put those on the edge. I think it was OpenShift. Yeah, I think it was OpenShift. Was an interesting project to get OpenShift on, but they were not Raspberry Pis. They were bigger than Raspberry Pi, so they were real big servers. Not big servers, but enough bigger enough to be able to run OpenShift. So it was kind of fun.
Oh yeah, no, just retired from Nokia. Yeah, we have anything that says 5G on it
5G, yeah.
has Kubernetes,
Oh wow,
and it's distributed all the way out. Those are called radio units.
that's what they're called. I didn't know
Yeah,
the name.
RUs, CUs, and DUs. You can Google them,
Okay,
and it's basically an architecture that tells the cell sites about the neighboring cell sites, so that they can control the signature of the radio frequencies
hmm,
to optimize coverage for the different user equipment. And
interesting.
the software unfortunately has to change a lot and needs to be
Mhm.
containerized. And
Oh.
OpenShift is one of the implementation
Yeah,
platforms,
one of
but
them.
not
Yeah,
the only. But
Mhm.
not the only. Some
yeah.
of our customers use different ones.
For Nokia, interesting. So they're called cell. I think I was calling it antennas, but I think they're cell
Mhm.
cell locations for that. Very interesting.
Um,
Hey,
Um,
quick question. Isn't it like one of the issues with Kubernetes is upgrades, right? Yeah, just it's having.
Yes.
So, what do you do with when there are thousands of implementation? Does it becomes really painful to upgrade? Is it an issue?
if you're talking about telco, it's a tremendous issue.
Oh,
And so I don't know how it's going to be completely solved, but some of our customers are just picking a version of Kubernetes and sticking with it until they have to swap it out, as opposed to every time, when 1.30 came out. I don't know, but I bet a lot of our customers I won't get to it for years.
okay. So, Jack, quick question: like, how many implementations are we like deployments are we talking? Like, is it thousands or tens of thousands in telco?
cell antennas. I'm getting like this. The
Yeah.
cell point of locations, right?
So each in the classic cellular network, each mobile network operator has tens of thousands of cell sites.
Yep.
5G blows them up and makes
Wow.
and makes each equivalent cell site a bunch of microcells,
I
and each
see.
of those is running containers. And it depends on the vendor. It depends on the customer what software is running in them, but uh, a lot of them are starting with OpenShift
Yep.
because the whole infrastructure, uh, it's just like an enterprise. Everyone wants something different, and so telcos want something different, so they can get it with OpenShift.
Yeah, I work with a I think it was a partner or vendor. They were before containers. There was a lot of things or software called network functions. Actually, there's a foundation and there's a framework. There's a whole thing on running network functions
Yeah,
on
network
the edge.
function
Yeah,
virtualization. Yeah.
yeah, exactly. That's the use case. It was
Oh, I can
network.
tell you all about it. I can
Yeah,
tell you all about it.
and I was switching VMs, and then they told me like, how do we upgrade the VM? And the VM has new network functions, and they just run on premises. And then that's where I started working. I think it was 2014, 15. Then they started asking like, if we were to run instead of VMs, more something lightweight, right? Like containers. How do we do it? Like not even Kubernetes, like just Docker, right?
Docker,
Um,
Docker containers.
how do we run these network
So,
functions?
so network function virtualizations were originally done on OpenStack.
On OpenStack. Okay.
OpenStack was everywhere. OpenStack was everywhere. And
Okay.
now, if you see OpenStack, OpenStack has VMs that are basically Kubernetes nodes.
Kubernetes nodes, worker
Yeah,
nodes.
yeah,
Deploy the worker nodes with
yeah.
OpenStack.
There's some of our customers that propose simply not even running VMs, just bare metal containers.
Bare metal containers. Yeah, operating
Bare metal
system
containers.
or lightweight. Enough operating system to run like a container
Yeah,
engine,
Core
right?
OS type stuff. Yeah,
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 yeah. Core
yeah, yeah,
OS or
yeah.
Flat Cat is another one.
Oh yeah, yeah.
Flat
Which
Car, I
it,
think.
it changes, and it'll end up being whatever the guys in the labs want versus whatever OpenShift or a commercial vendor is willing to support.
Yeah.
So it'll vary. And because of that, everything has to shrink really small, and it needs to be containerized. And the containers are good because the software versions change, and there's a whole architecture built in there to let you effectively A/B test or canary test and swap out.
The network functions.
Yeah, yeah. But how to change from one version of Kubernetes to the other, I don't know. I don't know how that's going to work. Yeah, shut off the 5G network for a weekend, and
Yeah.
I don't know how. Someone's figured that out. I don't know how. I don't
Yeah,
really don't know.
enough of a kubelet,
Yeah,
and that's hard per chip.
yeah.
Okay, so that yeah,
Anyway,
this is a good conversation in terms of context, right? So a lot of people ask online and like why would you run like containers on the edge? So I think Jack, thank you for bringing like real use cases from Nokia and Cell. So let me stop sharing and Sergio, go ahead and share.
well, yeah. Don't forget these cell sites. Microseconds are a long time.
Yeah,
It's just crazy
yeah.
how important the latency is at the cell sites because two different cell sites are talking to the same device, and the different phase shift
Between
because of the
them.
propagation delay over the air makes a difference on how much coverage you have and stuff. So it's
Oh wow. Yeah, yeah. This is the picture I think Sergio showed like
Yeah.
last week or something. Like, why would you do that sensor or that processing or communication like on the edge, and there's not enough time to go and connect to the cloud, right? To a cloud
Mhm.
provider to get piece of information or just to send the data there, so then it comes back to another point of presence.
Yeah, I think that Jack has more context about this picture.
Oh yeah, this is very close, Sergio. This is very close. This is the right idea. It's the thing you add in here is the transmission medium is like in the 3 gigahertz band, and
Mhm.
it just things are just going crazy fast, and software is really slow, and so you have to put
Mm,
the software modules in a place where it can add the most value without adding any latency.
Latency is the key.
Yeah.
Interesting,
mm. Yeah, pretty interesting.
fascinating.
You're from Nokia, Jack.
Mhm.
Ah, amazing.
There's
So,
another person who's on the call. I'm sorry, there a couple times there's a person from Toronto, from Ericsson on the call. He probably
Ah,
knows more about this than I do,
Oh wow.
or he has a different perspective, I should say, on it because it's this, how do you build 5G Kubernetes? It's like how did you do AI Kubernetes? How do you do 5G Kubernetes? So yeah, it's all over the place.
Jack, when we use our phone while driving, right? Whether you watch YouTube or play video game, everything is coming through Tower and Kubernetes.
If you're using 4G, no, you're not using
Okay.
Kubernetes. 5G, yes.
Oh,
Yeah.
I found the article. So yeah, I was not crazy. I was mentioning that I saw that the CNCF and this happened in 2019. So the CNCF launched the cloud native network functions test bed. So yeah, in CNCF there's a group of folks that are working in network functions and also working with Kubernetes. So that intersection between network functions is something before Kubernetes, right, Jack? Like that's something that you were talking about, the virtualization of those
The
network
principle
functions.
still exists. The
Yeah.
principle still exists, except its implementation on OpenStack is still supported, but is not the preferred method going forward.
Yep. Yeah, I wasn't
Oh,
sure
see
if it
there,
was like
yeah.
part of the
So
Linux Foundation or CNCF.
there's
Say
OpenStack,
CNCF.
yeah.
Yeah.
Yeah,
Yeah.
that's OpenStack. And so some of our customers wanted stuff on Google Cloud. Some of our customers wanted Amazon. Some like you've seen the press releases where AT&T is doing stuff with Azure. Our different customers want some of their
Ah,
network running in a Kubernetes environment inside of Google. And they go, no, we have OpenShift for some stuff on premises, and we have some stuff in Google Cloud. Make your Nokia, please make your solution work multi-cloud or hybrid cloud. And so one of our customers will have OpenShift servers. We have to put our software on that. And the same customer has other things running on Google Cloud. We have to put our stuff on that and make them work together. So multi-cluster, multi-cloud.
multi-cloud.
Yeah, that's
Yeah,
true.
there's the LF networking also. Yeah, there's a lot of there's the
The
space,
LFH too,
the
but
LF
I
networking.
yeah.
Oh, the LF Edge.
Yeah, there's
Another
I,
Cube
I know
Edge. I don't
some,
know where
yeah.
the Cube Edge. I think Cube Edge is just part of CNCF, right?
Yeah, I think that this LFH, some people of telco is working on that too. I remembered somebody that I was talking before about,
Yes. Let me
but
put the
they are
link.
from telcos. They are coming from telcos.
I'll put the links in the
Uh-huh.
notes so people can know what we're talking about. Yeah, there's LF networking. There's LF Edge.
Hmm.
Yeah, fascinating.
Yeah, pretty interesting.
Yeah, so that's interesting. So I didn't attend the K3s cluster talk, but just from what I know of it to me it could be it could be all the way out in radio units. It's got to be
Hmm.
really small. It's got to be very
Yeah.
low overhead. It's
Yeah,
got to
K3s is
Yes.
small. It
Pretty short.
doesn't. You
Pretty
can use
small.
it even with SQLite. Even like
yeah.
is the SQLite the default? I think so, right?
Yes.
Yeah, that's why it's very like the database heavy lifting is lightweight. And
Yeah.
it just runs a kube API and a kubelet. Though
But
in general, kubelet and API server have been like improved in terms of footprint
mhm,
for the past few years. Like and then
So I
mhm,
don't quite know how this works with Kubernetes. There's people who at Nokia who this is their full-time job. In
mhm,
5G, the cell sites are really green, and so at night, if they don't see any traffic, they will actually go to sleep.
oh, interesting.
mm,
Okay.
And I don't know if go to sleep means shut down, like power off, but
mhm.
it's telcos were making purchase decisions on how much power the cell
Yeah.
site consumed per year.
Mm.
And telcos are under net zero pressure, and anything new they
Yeah,
buy,
for sure.
they have to quantify how much current they're going to drain, so they can
Mhm,
calculate their net zero score. And if you can show that you can shut your stuff off in the middle of the night or when there's no traffic,
mhm,
your net zero score is easier to meet.
Yeah, the
And
sustainability, right?
yeah, so
mhm.
there's a certain amount of standby, which like we have on our laptop, but there's a certain amount of stuff that just gets shut off.
Yeah.
And
Yeah.
so I don't quite know. There's a big sensitivity to boot up time, very big sensitivity to boot up time.
Mm.
I would hate to think that Kubernetes would be uh, a negative factor for slow boot up time, but there's just cell sites that have to be shut off. It's the normal day cycle. Just like in the server room, nothing ever gets shut off. Cell sites get shut off, and I know historically they haven't been, but we've had so many customers just turning the crank and reducing total power because of green pressures. That's in the architecture.
Efficiencies, right? Efficiencies in terms of power
Yeah.
consumption. I remember I have family in Puerto Rico, so there was a big hurricane back it was 6 years ago, Maria, and there was the problem was the batteries at the cell sites didn't last that long, and people needed like cellular connectivity, and that was the only way to connect and have communication to say that people needed help or things like that. So the more
Oh,
efficient
yeah,
it
yeah, yeah,
is, the
yeah.
better.
So you heard about the Hurricane Katrina
Yeah, Katrina also Florida.
New Orleans. So
Oh no,
first
New
off,
Orleans, right?
New
Well, it went
Orleans, New
through,
Orleans.
yeah.
Yeah, so first off, the locals were shocked that there were so many cell sites that did not have some kind of backup, didn't have
Yeah,
a
backup.
diesel backup or battery backup. And the phone company very politely and diplomatically showed the meeting records from zoning meetings where the locals prohibited putting a battery on the roof of a building or prohibited putting
Oh,
a diesel
interesting.
generator on a site where a cell site was.
Interesting.
And so that was point one. Point two, the phone companies had big diesel trucks and propane trucks ready to go with for Katrina to go to the backups to refuel the cell sites, and the security people wouldn't let them in. So anyway, there's a whole story there.
Yeah.
Hmm.
Yeah, running on the edge is complex. It's a
Yeah.
complex area. So Sergio, that's the yeah. Go ahead, Sergio, for
No,
like
no, no. That's like pretty interesting to hear about a real use case, right?
yeah,
A
yeah,
big and real use case.
yeah. I gave the one of the Chick-fil-A, but
Yeah,
I think this is more critical than getting a fast food.
with last turkey and
Yeah,
everything.
it
Yeah.
was very critical, at least for my family back then. It's like it's very critical to get help, to get aid, so that communication. The longer that lasted the fuel or the batteries in those cell towers was critical, to the point that then they shut down, and then they send people over, like getting people over those cell towers to get fuel to them. So anything that can be done in software, right, to improve sustainability, like shutting down, scale to
Mhm.
zero, auto scaling, right, scale to one, efficiently, like save battery, save power.
Yeah, that's true. One of the experiments that I have pending to do is like use a solar panel to power the Raspberry Pi and do how many batteries going to consume and
Oh yeah.
lifetime. Yeah, it's something that I have pending to do too.
Yeah, I think for Raspberry Pi, it's like, is it 5 volt, 3.4 amps,
Uh, 3 amps.
3 amps,
Well,
3.4. Yeah.
depending on the
Oh yeah, depending
model,
on the
four
model.
or
Yeah.
three. Yes. And
Yeah.
that's true. The Raspberry Pi showed you a message that you have like low power and everything. And if you want to power another like a sensor or something, you need that 3 extra amps.
Yeah.
Yeah.
Yeah. You're going to connect something to the IO pins, right?
Hmm. So okay, let's continue with the databases.
Yep.
Or
I was
let me see. I think that I have no. Yes. We were talking chapter 2, 3, 4, 5, just basic configuration. Yeah, a basic multi-node cluster in the chapter 5. Certifications in the chapter 6. How to update the applications on the edge. Chapter 7, using Flux. That was like pretty nice.
using GitOps
Yeah, GitOps, using GitOps on the
and
edge
Flux.
with Flux. What else? This one was more the Longhorn. Let me see. Ah, no, the Flux part. Service meshes on the 8.
You were able to get service mesh running on the Raspberry Pi?
Yeah, the Linkerd.
Okay, Linkerd, I think it's lightweight,
Yeah,
more
pretty light.
lightweight than the Istio, right?
Yeah. Wonder if question for Jack. I wonder if you take like metrics about the edge devices that you use in some way. Can you tell us something? Metrics
Um,
about the networking traffic, or I don't know.
there is a big, thick PDF describing all the metrics that all cell sites, no matter what the vendor is, have to generate, and it's big
Mm,
and it's thick. And It's everything. It's everything from how many times when a mobile effectively giving you if someone's sitting there watching something and it spins, that generates a whole bunch of measurements. If you're switching from one cell site to the other, there's a whole bunch of measurements that get recorded there. If you switch from one cell site to the other and you drop, you disconnect, that gets recorded. There's all kinds of things. And there's tools that take all these measurements and create heat maps that you map it onto a geography where you can find holes in the cellular coverage. So it's huge quantities of data are collected, terabytes of data are collected
Oh
and
wow.
processed, and effectively you find holes. And some of the holes, where there's the coverage is good, you can in software turn up the power for the radios to try to create coverage. And in some cases, you have to change the tilt of the radio to get a little more
Mhm.
coverage
Oh wow,
out.
mechanical changes.
Yeah, but it's software control.
Yeah,
It's
yeah.
software control. And at
Interesting.
some point, and this is what all
Mhm.
vendors like, if you just put more cell sites in, you get better coverage. And of course, then it becomes a sales opportunity to sell more cell sites. So, so you put huge amounts of measurements in because it's billions of dollars to create cell networks.
Mhm.
And so the measurements are there for economic purposes. So it's a real business
Interesting.
driver to have all those measurements. And so the question problem is every time you add more measurements, is there a capacity to handle all that? And usually yes. Usually yes.
Oh, interesting.
Interesting. And also for planning, right? Where you're going
Mhm.
to place the next uh usage,
Oh,
right? If
right, right,
there's
right. Oh,
usage
yeah.
or not,
So
like that you can place a cell site, but you have to measure like how was the usage or
Mhm.
right. So the other thing is, and of course, with 5G, it's got all these new features in it. It's got all kinds of features for stadiums and
interesting.
events or campuses where you have a huge density, or airports,
Mm.
huge density, and all the cell sites are doing is the radio spectrum is the radio spectrum. It's finite. It's sharing that limited spectrum with as many people as possible. And if there's too many people, you have to put another cell site in and lower the power so that and so you can share that same spectrum in different spaces. And as you move from one cell site to the other, but you're still using the same spectrum. And so that's hard to do. That's hard to do. 5G actually makes it easier and better for the dense cases. Everyone wants to watch the replay from the football game in real time in the stands while they're watching the game. You're watching the game and you're watching your phone at the same time.
Yeah, just in bandwidth.
The 4G networks just didn't have the capacity for that, and you have to have lots of measurements for that.
Mm. Interesting.
Yeah.
So observability is pretty important on the edge.
Oh yeah.
Yeah.
Oh, yeah.
Okay. So I have like a diagram that you created, Carlos, but I
Yeah, that's
revealed
the.
using Excalibur.
It took me a while when I was doing the user experience for Knative to come up with with a mental diagram of like trying to explain what Knative is, and this is what I came with.
Yeah, I think that mentioning something important here. I hear the same story at the end of the Knative Con on 2022, right? That use kind of serverless function is pretty important on the edge because you can save energy,
Yep.
and the energy consumption is pretty important on the edge.
Yep.
That's the reason to include
So,
play.
Jack, if you're not familiar, like you were asking, like how do you shut down things in
Yes.
Kubernetes? In Kubernetes, we have our normal deployments that you can have one pod, but then if you have more requests coming in, like the normal way of doing like CPU and memory,
Mhm.
uh, you have an HPA that is horizontally like getting more pods, but it's always
Mhm.
one because if you go down, because what HPA is doing is getting the metrics of the pods and the two
Mhm.
pods and then three pods are they busy or not to get the fourth one and the fifth one. But the trick is if you delete all the pods and you get to zero, what do you measure? You cannot measure a pod that doesn't exist. So that's why you need one. So in Knative, this is a project that I work with. I co-created with Google and other companies. What we did here was we are able to scale to zero the pods, so you don't have any pods. And what we do is we put a proxy, a networking proxy. So when the HTTP request comes in, we go fast enough to go and spin up the pod, but that's a separate controller. That's not native to Kubernetes. So it will spin up the pod as more traffic comes in. We're measuring the traffic, not the utilization of the CPU and memory of the pod. What we're measuring is the metric of like how many requests are coming in or how many requests each pod is handling, like concurrency or the target concurrency. And there's use cases that there's, like you mentioned, network function. I think network functions was one of the use cases
Yes.
that a network function can only handle one request at a time. So there's usually in a web server, you just send requests and then multi-threading, but there's software written that only assumes that there's one piece of data or request coming in because maybe it consumes a lot of memory. And then if you have two, it just go out of memory. So that's why you need to have target concurrency, and you can set it to maybe it can handle one, maybe it can handle two. And then that's how we measure, like if there's too many requests coming in, then you can spin up more pods. So that's a project that is around that area, like saving
Oh, that's
energy.
really interesting. I just didn't know about that.
Yeah.
That's really cool. Yeah.
Yeah, and runs on the Raspberry Pi.
Yeah. Yep. Kubernetes. Yep. It's native Kubernetes. It's our controllers that run in Kubernetes.
Okay, the next part and the part for this day, the databases, right? So it's possible to run databases on the edge. So I tried different type of databases, right? I tried to investigate the most common databases that people can use. I included like different type of databases depending on the case. The default, K3s, a lightweight Kubernetes, includes by default. Well, you can use SQLite. That's the pretty smallest with
Yeah.
the less footprint database that maybe you can use on Linux, right? On a container. So it's an option, but if you need something more robust, maybe you want to use something like MySQL that all the people knows about MySQL, a document database like MongoDB, or a key value like Redis, or something like graph database like Neo4j.
Neo4j, very
Yeah.
popular. Neo4j is getting, I think, more popular these days. We have seen because of AI, because it's a way that you can store like the RAG to augment the Gen AI, like context and prompts, because you're looking for uh, graphing relationships, right? Not just relational relationship, but the graph to do a search on that. It's getting very popular.
Yeah, so when you connect to different objects, like for example, let's say a story, right? In the story, different characters are there, and you want to connect those characters with different things. So that is where the new 4J comes into play, right? So, like for example, maybe in for a car, right? You have engine, you have brakes, and so on, right? They can be an entity, and how they connect together can be part of that.
Yeah,
Yeah.
yeah.
Yeah. So right now, if you want, I can try to install a database on the Raspberry Pi.
Yeah, let's do that. Because I was reading, I was wondering how do we create a PV or PVC? Like I know, back in the day I
The
was
part
using Rook FS was very popular. I think I used that with different tools.
Yeah,
And
let's
then
say
you
in
say
the
Longhorn.
yeah,
Let's
in the book I use a Longhorn, but I think that, well, the steps to install Longhorn right now is deprecated on the chapter.
Oh,
So
really? And but you
yeah,
also mentioned that it was more lightweight than Rook. Did you did the comparison of like both? The Rook
uh,
was like more heavy than Longhorn for the Raspberry Pi.
I don't remember. I think that I didn't include it, but I think that based on blog post, I found that the people was saying like, or maybe I found like a kind of test about which one are more heavy, or about RAM consumption or CPU maybe.
Can you show the website of Longhorn and Rookfs so just people know the context what we're talking
Yeah,
about? Sometimes
Longhorn.
uh,
Yeah, let me see.
Kubernetes maybe.
Ah, Longhorn Kubernetes
Oh,
state.
Longhorn is the Portworx. That's why I
Yeah.
was saying I usually know. Yeah, Portworx say like they've been around for the longest time. Good partner
Yeah.
of like cloud providers. Yeah, they've
Yeah,
been
let's
around
say
for a
that
long time.
the context about Longhorn is like because it's a basically it's a bare metal cluster to deploy Kubernetes on a Raspberry Pi, so you don't have like well you have a storage but using directories inside of your Raspberry Pi. But if you want like a kind of simulate or to extend that functionality, you need to, let's say, for the people that is new in Kubernetes, to install a kind of driver to support that features. So one of the, let's say, easier ones and prepared for the age is Longhorn, that is made by Rancher, and right now is part of SUSE. So Longhorn can simulate that a driver for storage and give you more power on the persistent part, right? That you need for the containers. So that's the reason I was not sure if Rook it wasn't supported in that time, Carlos. Maybe was the reason to include Longhorn.
Ah, yeah. Rook
Be,
Rook is some Rook Ceph, right? That's
yeah,
they use Ceph.
yeah,
And Gloucester FS. I'm trying to remember. I'm
yeah.
working with a cloud provider,
Mhm,
so now like the answers are very easy. Like you just
mhm,
use everybody uses the same thing, bread and butter. But back in the day, I was
yeah,
experimenting with a lot of
yeah. I
these
think
things.
that maybe wasn't supported ARM in that moment when I was like
Ah,
writing the
ARM.
yeah,
Okay, yeah, that explains.
yeah.
And
I think that was
Longhorn
the
is from Rancher, and Rancher was K3s. So
mhm,
probably someone wrote a blog post, right? How to get
mhm.
or test it like Longhorn works in K3s, right? In Raspberry
Yeah,
Pi.
yeah. I think that was the reason. I think that was the reason. The
But
other one, yes.
one thing that you mentioned was for like you're mentioning like the Longhorn it has an implementation of the container storage interface
Hmm.
CSI, right? That's
Hmm.
the driver in Kubernetes that
Yes.
allows you to implement the resources like PV and PVC. But if you are working, I was going to start with host path, like to
Ah,
try to
yes, yes,
understand how
yes.
things work.
Yes, the
You can
local
also create
directory.
a
Yes.
you can also, which is a like we were talking in the last section, we say like, well, we want to use Kubernetes Raspberry Pi as similar as you would run it in maybe in a
Hmm.
managed cloud or somewhere
Yes.
else, because then it's easier to
Hmm.
have the configuration. Then
Hmm.
your configuration works here, works over there, and
Hmm.
there are not a lot of assumptions like
Hmm.
in the cloud. You don't have access, like root access to the worker
Yes.
nodes. You want to throw them
Hmm.
away and get a new one. Raspberry Pi, you get one and you
Hmm.
cannot throw it away. That's the only one that you have, so you
Hmm.
have to babysit it. But you can do host path and basically say
Except
use this folder
to store
in
the.
this Linux
Hmm.
OS, and then I have, and even with the CSI, I need to figure
Hmm.
out. I bought the NVMe, so I will have a second hard drive. I have the SD card,
Uh-huh.
but I have a second hard drive.
Hmm.
So it's a matter of like creating a PV if it's
Hmm.
host path in that folder that is the mount
Hmm.
volume on the new
In
disk that I'm going to put.
the file system, yes.
But if it's CSI driver, I think it's to be the same, right? Install the CSI driver, and by the way, your
Hmm.
storage is
Hmm.
this mount point or this folder versus
Uh-huh.
the SD card, right? The OS
Mhm.
one.
Yeah, let's say that. Yeah, in thinking about a single node cluster works really nice. But well, as you know, on Kubernetes, all the people that is new in Kubernetes, if you have multiple nodes, this thing is going to save your data in one folder in a specific node, or at least in the node where the deployment or the pod is living, right? So if let's say that the next time or for some reason the pod is going to be recreated or restarted, maybe it's going to be deployed in another node, so
No,
your information is going to disappear. Let's say at the perspective of a user that doesn't know is where's my data, what happened.
yep,
So
yes.
and that's my reason to thinking about on scaling an edge cluster with more nodes. I decided to include a Longhorn as the, let's say, as the software to give you the ability to move your data between nodes or something like that, right?
Interesting. So Longhorn does data replication between the nodes.
I think that this has a lot of features.
Okay.
For example, I remember that uh, only one pod or deployment can write at the same time in the driver. So if you use Longhorn plus NFS, you can support the that simultaneously certain pods can write to the same place, right? So Longhorn can give you the ability in that way, in a simpler way, instead of installing a lot of things, right? So because of the simplicity of Longhorn, I decided to include it in the book, this software, right?
Yep. Yeah, it's different modes. So if you're learning Kubernetes, watching this, there's in the Kubernetes doc, right? We can include the document to that. Like you have read write once, read write many,
Yeah,
and then
yeah,
I think Kubernetes 129 added a new mode of the
yeah.
only allowed yeah, I think it was 129. They added only allow one pod to
Hmm.
write
Yeah.
on this node because
Hmm.
the misperception, and it was a
Hmm.
misperception back in 20, I don't know,
Okay.
20 when the CSI came out.
Yes.
The most common misperception that people have when it's like read write once, they think that when you have one pod, it can write to that node, that storage, that PVM PVC. If
Hmm.
you have a second node, people think, oh, that it will never like write to the same place. Well, it can if it lands in the same node
Hmm.
because the read write once is
Hmm.
about node, it's not about pods. It says
Yes.
anyone can only write on this node, right? If they land in the same node.
Yeah. The other thing that I discovered, I was like hesitating about including Longhorn was this OpenEBS. I don't remember if OpenEBS at the beginning was a fork of Longhorn, not sure, or vice versa.
OpenEBS.
Yeah, but OpenEBS has like pretty nice features for storage in
Oh,
terms of,
another Cloud Foundation CNCF project. I
yeah.
wonder if there are. I'll double check if there's.
This one is pretty nice too. So it's something like pretty interesting to explore. But in that moment, didn't include like,
No, I don't think so.
yeah, in that moment, I this one didn't include a UI to manage the stuff. So right now,
Okay.
yeah,
The Longhorn has a UI. I think I saw in the
yeah,
book.
yeah. So this one, I am not sure right now if they have like kind of UI or something. I think for an new people starting on Kubernetes and edge devices, I think that the UI is important. So I decided to include Longhorn instead of this one, right? But this one is pretty nice too. I found that Longhorn has like several issues when they upgrade from versions. It feels a little bit unstable in general. Right now, I don't know, but OpenEBS feels like a little bit more stable in general terms. But
Interesting.
yeah, was my perception when I was trying to install, upgrade the things. Yeah, and also I remember that Longhorn started to give errors with the storage and that kind of things when the cluster restart, and OpenEBS was more stable in that scenario. But both, I think that works really nice.
Yeah, it looks like Longhorn has more features than just like implement the CSI. It has like
Yes.
backup to secondary storage. It says
Mhm.
backup to secondary storage like NFS or S3, incremental
Yes.
snapshots of
Uh-huh.
incremental the snapshots. Like that's a Kubernetes resource. Like it's the snapshot, right? So I'm guessing they're implementing that API.
Yeah, I think that for me, if you ask me today, I will choose maybe OpenEBS for simpler thing, and if I don't want a UI, but that was on that moment. Right now, I don't know.
I see
I,
they implement. I see that what you mean. They implement the read write many with an
Mhm.
NFS.
Yes,
Yeah,
on Longhorn.
NFS is like this. Yeah, the same way we have EFS in
Hmm.
EKS. It's a
Hmm.
network file system, so multiple nodes can write to the same folder,
Yeah,
for example, files.
yeah, that was like a little bit about it. So let's deploy a database. I think that we have 10 minutes.
Yeah, you have it ready. I didn't know you had it ready. We were
Yeah,
discussing.
let me see. Let's be fair and read the book here in the chapter 10 and try MySQL.
While you guys are busy with this, I um, I had the chance to join a session that was emceed by Kelsey Hightower in
Uh-huh.
Paris in the last KubeCon.
Uh-huh.
And obviously, people gather around him and ask questions. And one of the things was databases on Kubernetes. And he was really opinionated about that. You shouldn't have databases on Kubernetes. So there was a long discussion between this person and him that, like, he really didn't like it at all, apparently. I didn't know. He has written about it in the past. So somebody asked about, if his opinions changed, and he said no.
Okay.
Doesn't reflect my opinions. Just wanted to share this conversation, heated conversation.
Yeah,
Yeah.
it depends. The answer as a right a good solutions architect is it depends.
Yeah, that's a
So
great
so
answer.
if you have
Depends on
in this
the.
case, right, we're talking about a
Yeah.
Raspberry Pi sitting on a cell tower
Yeah.
that it needs to store some data and a little application that needs an SQLite or a MySQL, right? You
Just to
cannot have the
store, yeah,
database
just
in
to, yeah,
AWS
exactly.
to for the cell tower to go to the database to do an SQL query, right? So it makes sense to run it locally. You can run it in Docker and not necessarily in the in Kubernetes cluster as a pod, but that database needs to live in that Raspberry Pi.
Yes, that's true.
But yeah, the alternative is, and this is, remember when people ran a pod that has the SQL or MySQL server, but there was no operators. So the first operators that got created was to manage a database, because the database is not as simple as like running a container and then that's it and give it some
Exactly.
storage, right?
Yeah.
Like it's all these extra runbooks that you need to run on databases when you are upgrading and backing up and dealing with the logs, all those things. That's where like a lot of operators came out, and then some vendor versions of them. So yeah, do not run a database in Kubernetes without an operator if you're
On
going to do
pod.
it for production, right?
Yeah.
If
Okay.
you have to run it in Kubernetes, right? If you can run it um, as a SaaS or as a service from a different provider, they're running like that. And even to the point that I have given prescripted guidance, if your organization, like a big corporation, wants to run Kafka, not even a database, like stateful Kafka or databases, run it in a different cluster, and this will be a different team because it's the Kafka team or the people DBAs running in a different cluster, and then provide it as a service. You don't have to tell that team doesn't have to tell anyone that they're using Kubernetes, right? But these provide as a service, so the other clusters that are using the stateless apps connected to the database, like use it as a SaaS, right? As a service.
Okay.
So you already had Longhorn installed?
No. So I deleted the part of the storage.
You deleted what?
The part of the storage of the storage driver using Longhorn just to have like a regular deployment of Redis. Well, I choose a Redis in this case as a key value database to
Well,
deploy
where's the
on the.
PVC?
No, I am not using a PVC right now. Just like show that the database can run on an edge device.
But yeah, okay. So it will be writing where, in ephemeral?
Ephemeral, yes.
Okay, okay.
Just to show that you can deploy a database on a Raspberry Pi. Okay, it's running.
But not persistent, right?
Not persistent.
Yeah.
I have the configuration here, but just to show it.
Yeah, yeah, yeah.
Just let me.
And Redis sometimes people run without a PVC, right? Because Redis is a cache
Hmm.
to accelerate data, right, between stateless systems.
Yes.
So if it dies, that's okay. You come up and the app will search for a key, and if it's not there, it's a hit, right? So that's okay. It will like hit, write the data, and then get back. So it's the next the net request that it needs that value from that key will find it. So it's not as critical as saving like business information, right, or like the critical information that you want to keep track.
Yeah, so it
Time
works.
series database, right?
Yeah, so it works. I'm using like a key value database, Redis, setting a value buckload with a value KS on H and getting the value, and it works.
And I guess you
So,
can use the new image, right? The what is the new project from CNCF? Is it key value?
ah,
Key value, the new project,
bulky,
Valky. I always have them
bulky.
revert. Why would they call Valky? Like in my mind, you have the key and the
Uh,
value. Like I read from left to right.
I think that we can explore in 4 minutes for fun what happen if they have a bulky image.
Valky image,
Let me see.
CNCF.
Ah, Vietnamese bulky. Okay, let's explore.
Well, from their
Uh,
GitHub page, they should have something, right? The container.
yeah, I think that this one, the Vietnamese image. Just let me see if they have ARM tags. Ah, yes, they have ARM. Oh, pretty interesting. Let me
Valky
copy
from
the.
Vietnamese. Yeah, Vietnamese images are good because they're
Yeah.
configured as non-root. So just as a tip for
Okay.
people that are like
Let's
looking for
try.
good images.
Let's try my Redis. Okay. Keep cuddle, delete my Redis. Okay. My Redis, my Valky. Okay. So,
And it's the tag is the one that says ARM.
yeah, it's supposed that is multi architecture. Let me see.
Oh,
Yeah.
multi.
Yeah, multi architecture. Yes.
Yeah, if you're looking for images that run in Raspberry Pi, take a look at the
Yeah.
architecture. It needs to have either
ARM.
specific for ARM64 or multi-architecture, which have multiple images in one.
Uh huh. I suggest to use all the time ARM64. Is more. I think that they have better support.
Yeah,
Just let me see. Valky.
you can leave
Valky.
everything else the same, right?
Yes. Ah, that's true. Valky and Valky. Okay. Let's see what happens. Now I can put in my resume. Okay, I can use Valky. I am expert.
Yeah. Let's see, Docker.
Let's see. Get posts. Valky. The containers was creating.
Interesting. I'm looking in their GitHub repo and they don't publish images. So Vietnam is doing
Ah,
them
it's
a favor.
running. Ah, it's running. That's cool. Exec. Let me see. Okay. Um.
And
Uh,
what will be the client then in that side that image?
the CLI. The container not found. Let me see.
It's only one container, so you don't have to specify the container. No.
No, I am not specifying the container. Unable to upgrade connection container not found bulky. Wait. No. What is happy with bulky?
Error. Yeah, check
Yeah.
the be exiting with one maybe. What does it say?
Back off restarting. Maybe an
Yeah.
internal thing, right?
Yeah. Check the logs. Yeah, crash
Yes.
will back off.
Mm,
Bitnami Valky container. Valky password environment it's empty, not set. Set the environment variable.
I think that you
Oh,
should.
allow empty password equals yes. You have to be explicit then.
Yeah.
Yeah. So you have to allow empty password equals yes, and then um, interesting. That
Yeah.
was
So it doesn't work like a regular Redis, right?
well. This is better, right? You're explicitly saying that you configuring it with the password like secure.
Yeah. Let me see. I think that with
Because
Redis.
usually the risk is when people like deploy apps and deploy Redis to use it as a cache. Usually sometimes the information they put in the cache are like the bear tokens or access tokens, like and that's like sensitive secrets, right? Temporary secrets.
Yeah.
And
Yeah.
it
Yeah.
only takes some other pod to have network access, and the customer doesn't have network policy to access that Redis, right? And they can get access because the default
Yes.
doesn't have a password.
Just let me remember value, and they want the
Yes,
and just right.
weird they have yes instead of true, right?
And that's it, right?
Yeah, do I replace or delete?
I know. Okay. Apply. Save my Redis.
Yeah, or apply.
It's running.
Yeah, check the log.
Logs. This one is a deployment, right? Deploy
Yeah, you can do a deployment. We'll pick up the.
bulky.
Yeah,
Yeah, yeah, yeah.
but I don't think that's what I was saying. I don't think the client will be
Maybe it's
named
the same.
Redis,
Let's
right?
see. Let's see. Let's see.
Maybe it's
Exec,
called
right?
Valky, the client CLI,
Yeah. Let's see. CTL. No.
or maybe there's an alias called Redis that points to that, just to have not have problems with legal.
Yeah. Wait, wait, wait. Exec. Okay. Bulky. Copy. This is a kind of crash loopback show.
Yep.
Let me see. Okay.
Yeah,
I
you
have
got
no
it.
name.
Okay.
Bulky? Bulky CLI.
Yeah. See, it's going to be Redis. Yeah.
Set Bucklow. Bucklow. Cool shows with Carlos and Sebi.
Oh, so
I'm
nice.
here. I'm still. Yay! I thought you forgot about me.
Yeah, we got Valky running on a Raspberry Pi. Maybe we're the first ones. Cool.
Yeah.
That's cool. Yeah.
Cool. So yeah, people can try the instructions in the book, or just go to Longhorn, right? I think they have a helm chart that they can
Uh-huh.
install. Um,
Mm-hmm.
and at least from the book, it was like the default just work on Raspberry Pi. So um, people can give it a try and
But a
connect VVC to it.
Mm-hmm.
quick question though, that I mean, of course, on the edge, we would need persistence, right? I
Yep.
mean,
Yes, yes, yes.
so like, what I mean, you can use like Longhorn or OpenEBS with some storage there,
Mm-hmm.
Yep.
Yes.
and then how do we manage basically? I'm kind of going back to the same the use case of mobile, right? Cell devices, right?
Mm-hmm.
When you kind of somebody moves from one cell to another cell on the mobile network, right? How
Mm-hmm.
does their data
Data
get
doesn't have to
stored,
move.
right? Yeah,
Like it's
Mm-hmm.
a
that's
cell
basically what.
tower. Like the data stays on that
Mm-hmm.
other tower one, and tower two has a different database.
Right,
Mm-hmm.
right. So how does that work? I mean, it's like data has to move along with along with the person as I'm driving the car, my data is moving along with you. I
I
don't
don't
think
think
so.
so. I don't. I don't think so.
Yeah.
That would be too much actually.
Yeah,
Yeah. I think that
yeah.
is pretty
But
interesting.
it's a like I think you were getting at is like it doesn't matter if it's a cell tower, Raspberry Pi, or two computers, or three PCs, or two or five AWS instances, right? You have Kubernetes, you have CSI drivers, and they have storage. So if you want like read write many, like Longhorn, we were talking about, Longhorn has uses NFS, so you can install NFS, and all of them are connected to an NFS server, right? So the storage is shared. So
So I believe that
instantly it's showing in the other
I
one.
think and it's just a kind of a connection string they might need to kind of go along with it, right? Because see, whatever the data we have on a cell tower, it's just a connection, right? And then as long as they can serve that, it's perfectly fine because data is belonging to local on our whatever we are doing right on our mobile, right? It is the connection they have to ensure that connection goes as you travel, right? In a way,
Yeah.
yeah. That
Uh,
I
the
think is
type
not.
the type of data, I don't know. The type of data may be
Yeah.
the one that Jack dropped, but Jack was saying like the massive amount of measurements, right, or
Mm.
metrics being saved and then eventually collected. I'm guessing like right, eventually collected, which would not be about your specific phone call,
Mm.
saved to a database in stateful. But
Yeah.
yeah, I forgot about OpenEBS. I think I have used in the long past Longhorn, Portworx, RookFS, GloucesterFS, NFS, HostPath.
Hmm.
There's so many. Like I don't know if we want to show there's a Kubernetes page that has all the
Hmm.
CSI open source projects and vendors. Actually,
Yeah.
yeah, because I was
Hmm.
reviewing one of those for AWS,
Hmm.
and it mentions also the vendors there,
Hmm.
and people can use that. Um, but yeah, this is cool. I'm going to set up mine. I got a this 256 NVMe. I can post those in the link.
Hmm.
I got a specific one, M.2 SSD,
Hmm.
and I got a hat because of the Raspberry Pi has a PCIe. So with PCIe, then you can put a PCIe board that looks like this. This is the board, and
Hmm.
basically you can connect an M2. I think it's called M.2 SSD.
Hmm.
So this is an M2 SSD. So I will have storage, but you can connect other things. Like there's other hats that can support two
Hmm.
M.2s, so you can have a storage and something else, or two hard drives, or I can get the AI, the artificial intelligence
Hmm.
neural thing that we saw last week for
Hmm.
Raspberry Pi
Yes.
5. I can connect it here. So I was going to plan to also get it, and then I use the hat for like playing with the SSD and the AI to see if it's good enough to do neural stuff. But yeah, I think it needs to be Raspberry Pi 5 because that's the one that has PCIe bus, right? And then
Would
this is
love to
just
would
a
love,
connects to it. Go ahead, Nabil.
would love to see that demo, right? Like when you configure the AI chip on top of it, if you can, right? And what kind of model we can run on that.
Yeah, I was looking at what are the different models. I think Llama.cpp. I will need to compile Llama.cpp.
Mm.
Okay.
Um, and that's the one that I think people were. I was searching Raspberry Pi and AI models, and I think I found a YouTube channel. I can also put that in the links if people are interested.
Yeah,
Okay.
I think that you can also check for TensorFlow Lite. They have a lot of support
Oh, really?
between neural network devices and machine learning models with TF Lite. Uh-huh.
Oh, like the
TensorFlow
ones that
Lite.
we discussed some other
Mhm.
like hardware. What was the
Mhm.
family of hardware? The
Yeah,
Coral?
the Coral with Google and the Intel neuronal network. I don't remember the name, but this is a blue one.
Mhm.
Maybe we can talk the next week about machine learning
Yeah,
on the edge.
yeah. Maybe I can get one at least one model running on my
Hmm.
Raspberry Pi 5.
Hmm.
But it can run on CPU. Some of the models
Hmm.
just run on CPU. So the
Yeah.
AI neural networks to accelerate, maybe to compare. We can compare if I get the
Hmm.
other one right. But each
Hmm.
in CPU, you can compile the model with like when you compile the model, you can say like how many GPUs do I have, right? You can say
Mhm.
0. You can compile it like if you don't find a GPU, then
Mhm.
it doesn't do the acceleration, and it
Mhm.
just do the CPUs. Or if you
Mhm.
have multiple GPUs, you need to compile it like I have 2 GPUs, use both, those type of things.
Mhm.
Well, yeah, let's try to see if we can get some AI on Raspberry
Mhm.
Pi next week.
Yes.
That's a
Great.
good use case. And then we have an expert, the Pina can answer all our AI dumb
Yeah.
questions.
I think that my experience is more like depurating which software can run on the edge and which one not. So, and how to troubleshoot that problems. I think that that's my experience in general about the edge. Which ones fits better?
Yep. Yeah, processing the input on
Mhm.
the edge, like dealing with an image or a picture that you take,
Mhm.
or video stream, right?
Or video
As
stream.
usually that's the use case where you like, I have a friend that configured one for, I think it was for Ring or some of the cameras. Like it
Mhm.
detected in the house, it detected that they were like the owners of the house, like the family versus a stranger. So it was able to detect this is a stranger and this is like part of the family, just real time in the camera with face detection. Okay, so stop the recording and thank you so much. So this is the new time.